This makes us here also feel much better, right? So because we are starting in a moment, and it's a great pleasure to have you all here in the room for this panel discussion. A good morning to everyone and a warm welcome. We have here today in this panel discussion a quantum future joining forces of academia and industry. We have very distinguished guests and we will discuss a very hot topic. So I'm sure it will be an exciting discussions. And also all you here in the audience, get prepared because there's later also time for you asking questions. So please get prepared. So my name is Heike Riel. I'm an IBM Fellow and Head of Quantum and AI Technologies at IBM Research in Zurich. And I have this great pleasure to today moderate the panel discussion. So, quantum. A quantum future, joining forces of academia and industry is so important. I mean, we are today, or this year, celebrating 100 years of quantum, the International Year of Quantum Science and Technology. And a lot of things have happened over the last 100 years, which we on a daily basis enjoy and use and makes our life better in many different things, whether it's lasers, whether it's MRIs and other instrumentation, which we really already use today in life. So, but this is just the beginning, as the community said. So, what will the next 100 years bring? And we expect also here enormous opportunity in this utilizing the second quantum revolution, quantum computing, quantum sensing, quantum communication, and other technologies. So how can we, as a community, create a quantum future that is bright, helps and advances our society, creates new insights and economic value? So the goal today is create this quantum future by joining forces of academia and industry and discuss the challenges and the advantages. And so let me first introduce also the panel speakers here. We have Stefan Philipp, Professor Stefan Philipp from Munich. He is one of the two CEOs of the Munich Quantum Valley and a full professor in physics at the Technical University of Munich and director of the Walter Meissner Institute of the Bavarian Academy of Sciences and Humanities since 2020. And he's a true quantum expert. He is working on quantum computing, superconducting qubits, and other things. Then we have Professor Ian Wamsley, director of the Oxford Quantum Institute from UK. And he's a member also of the UK government's Quantum Strategic Advisory Board. And he has a rich career with many different high-level academic institutions where he not only was a researcher, but he led and guided them and really drove the field forward. So we are very honored to have you also here. Then we also have here Amy Gunther. Dr. Amy Gunther, Program Director, Quantum Networking. And since early this year, she's Program Director launching the Quantum Internet Working Challenge Program at the National Research Council of Canada. And before that, Amy was part of a similar program on quantum sensing. She's a quantum physicist. She did her PhD in quantum optics and also has a rich experience in bringing science into innovation, into industry. And then we have a true expert also in both sides, on the quantum science, but also on the industry side. Dr. Sebastian Blatt, he is CTO and co-founder of Blank. And it's a startup. And the startup is in Munich, and the idea is, and the goal to build scalable and energy-efficient quantum computers based on neutral atoms and optical lattices. So he had a rich career also in the academia. He has been at Harvard, the University of Colorado, LMU, Max Planck, etc. And then he took the step and the risk to create a company. So we are very happy to have you here and learn more about this moving forward. So now, the major question I already mentioned, how can science and industry collaborate to accelerate and promote technology transfer? What are the important framework conditions to make this successful? And we're very happy to have from UK, which has already started very early on quantum technologies and invested, also from Canada and also Munich Quantum Valley. So let me start with Stefan Philipp. There has been in Bavaria extremely strong, and in Germany extremely strong quantum science, combined also with strong engineering capabilities at Fraunhofer and other institutions. Also the high-performance computing Leibniz Rechenzentrum. So significant investments have been done in the Munich Quantum Valley in particular, in the initiative where you are the CEO. And so what is the Munich Quantum Valley, right? What is the goal of the Munich Quantum Valley, and what are there the framework conditions, what works and what does not work?
So what works is that we have started off 4 years ago, kind of as a wake-up call to promote quantum computing, quantum science, quantum technology, and push this technology and bring together now all the actors, as you said, within this ecosystem to work towards a common goal. And what is the actors on the stage is the universities. And the universities are excellent, or the institutes, Max Planck Institute, and the universities, they work on excellent science. But what's lacking is how to bring this science into technology. And there is, for example, like Fraunhofer Institute or so that can do this technology transfer, but in working towards this common goal and building this complex system, this quantum computer, you need to bring the actors together. And that's what we have started, and that's what we are at the moment encouraging and fostering, that we build this ecosystem so that's possible. And we have reached excellent results in the last 4 years or so, and now is the point that we have to move this on and bring this to the next level. And there, for example, we have startups that have already emerged. Planck is one, but we have also others like Peak Quantum from the superconducting qubit side, here the neutral atom side. And now that we start seeing that it's going to work and that we are fostering, or that we are actually getting to the stage where we have the academia and the industry and also the companies are working together and using all the expertise and all the technology that's around. What works? I think forming this ecosystem means that you have to talk a lot, you have to bring the people together, you have to have some plans, and you form a common vision for that. I think that worked and then will work in the future and also in the next years to come. We have managed to have funding, attract also funding from the federal, not only the state of Bavaria, and get this going. What we need to work on, or what will work in future, I have to say, is even making this easier, making this technology transfer easier. Then there's question about how to come to a common understanding, how to deal with IP, how to make it easier as for startups to go to a one-stop shop, and so that they don't have to talk to all of the actors on the stage, and then facilitate that you can simply, easily and fast actually move on and progress so that companies benefit from the academic environment and that you make this transfer as fast as possible. And there is hurdles that still needs to be kind of solved. Working on that, and we are kind of confident that that's the way forward.
Super, thank you very much. Thank you very much for giving us this insight into this initiative, where I guess the next phase is now getting also started, right?
So we are about to start now the second phase of this initiative, and then going along this journey and even more enabling more startups, enabling the existing startups, having also this, we build quantum computers, we make them operational, build the excellent technology in there, also make it available for user access. So kind of if companies are coming and want to test and try what can be done with quantum computers, and we combine all these aspects in full stack quantum computing enabling technology.
So let me then move from Germany to UK. So Professor Wamsley, you have in the UK already in 2013, if I'm not mistaken, started a very strategic investment into quantum technologies. Quantum hubs have been generated. They had a 10-year program, a really long program, and it got renewed last year. And so you have been also in different functions part of this program, right? As a researcher, professor, but then also as a provost, as now at Imperial College, and now the director of Oxford Quantum Institute. So what different frameworks, what different conditions are there? And also here, what worked, what didn't work, that we can analyze a bit better of the different things and figure out what is really best and define a best practice.
Yes, you're right. It's been a 10-year program that's been in place now, just over 10 years. And importantly, there is a strategy for the next 10 years as well. So that's a 20-year, multi-billion pound investment in this sector. And that builds upon a prior 20-year investment in the science. And I think that's important, that there's a lot of ideas here that need to go into the ecosystem. The intent of the hubs, which are now in their third phase, and there's five now, but originally four, one in computing, one in sensing, one in communications, one in imaging, now moving to PNT. So those were really intended to build a technology sector by taking ideas from the scientific side in universities and helping to drive that out into the economy. And that was there were two elements to that. One was around engaging users, building a user community, and engaging existing companies to understand how they may use quantum. And the second was to begin to seed the ecosystem with new companies. And I think those both have been successful. There's been a very large number of startups out of those hubs. Recently, some have done extremely well, reached unicorn status. And also, there's been a big engagement from industry and user applications. So about 5 or 6 years ago, we set up a National Quantum Computing Center, which was intended to build a sort of test bed where industry and users could engage with machines actually live in place to be able to see how they may benefit their business. So I think those things worked. One of the challenges is how do you grow that beyond the early stage set of companies? And there, one important set of actors that you didn't mention, of course, is the venture funding, because public money is a critically important seed when strategically applied, but it's never going to be enough to really grow the industry of the future. So that's an important component, and that's clearly where the US has a big advantage over Europe and the UK. And that's, I think, something that we need to be thinking more about if we want to have our own capabilities within this region.
So let me ask you a bit deeper, because as you said, right, there have been great examples of startups which have been started early and now grew very big. Mm-hmm. So what was the secret to have them also growing fast?
Well, I think in the UK I would say we've cracked it, but it's probably not everybody would agree with me. The low threshold of getting ideas out of universities into startups. And of course, the important challenge there is making sure that the academic side is suitably incentivized to make sure this happens. And the way that happens now in the UK is largely that there's a very low threshold for licensing IP, but there's usually an equity stake that gives some return to the founders or the participants and the institutions. So I think that does well. We've got very good funding around seed and initial investment, and good communities of entrepreneurs in residence and advisors to help companies get up and running quickly. I think going to the next stage, when you get to your second and third funding rounds, is a bit more of a challenge. And that's where you see a lot of investment coming in from elsewhere across the world, and particularly the US.
That's what you mentioned, that we need there in Europe also more venture capital, more private funding to go into the... That's
right. There are others more expert than I, but I think there is quite a lot of capital around in Europe, but the way it maybe is deployed is not as adventurous as the US. And perhaps one of the reasons is clearly you've got to get a critical mass before that becomes viable. If the probability of success is small and you believe you've got an accurate way of assessing things, the only solution is to make multiple bets.
Yeah, thank you very much for sharing these insights, very valuable. And then let me ask you, Dr. Gunther, so Canada also has very strong investments, very strong scientific research teams, and has also different and interesting concepts how to make science and industry collaborate and work together. I personally had experience of a hub, not quantum, it was a different one, where really industry and academia, local industry, etc., small businesses and bigger industries worked very, very closely together. So can you explain also your experience, your learning, and what's the best framework to collaborate? What are you using in Canada, and also there, what works, what doesn't work?
So in Canada, we have 4 main hubs around the country that more or less happened organically. Canada, despite being pretty small in population, though of course very vast in territory size, we actually have one of the most highest quantum startups per capita, regardless of where we are in the world here. So we've invested in quantum early, and it got lucky a bit there, and some really great things kind of panned out from there. And some of those key investments went into what became hubs in, say, Vancouver on the west coast there, and in Calgary and near the beautiful Rocky Mountains and the Sherbrooke. Of course, everyone knows about the Waterloo-Toronto areas and all the stuff coming out of there. So these places have had really spun out a lot of startups around this rich ecosystem there. And one of the things, as I'm working now in the quantum networking space, that what I'm hearing from our ecosystem is you need to bring all the different types of expertise together, that heterogeneous pieces of moving with atoms, moving with superconducting. How do we talk together? And we've had really great engagement between the folks to really help commercialize it. So we have a national quantum strategy that came out in 2021, which more or less was kind of like what everybody else's is, research, talent, commercialization, quantum sensing, communications / post-quantum crypto, and computing. So that's there. And that gave a kickstart of about 360 million Canadian over 7 years. It's about more or less half done. But a few days ago, Canada dropped its federal budget, and there was an quantum ecosystem investment almost doubling that. Of course, we'll see next week if the budget's going to pass here, but this is something in 2025 here that Canada has been wanting to push down in some of these areas. So what hasn't worked, so one complaint we've often hear from our ecosystem, so we're nice people in Canada, is we spread the peanut butter too thin. How do you make choices? Because a strategy is about doubling down on something. You have to choose something. And quantum has been a particularly tricky one because, well, what platform's going to win? Like, if we're going to just pick a quantum computing platform, like, which one here? In Canada, we have three of the top quantum computing companies, and they're all in different platforms. Which one's going to get there? Do you just pick one and go for that, or in the sensing and communication space? So I think there's some natural hesitancies about making a bet too soon, or really just making a bet in general. So that has been tricky. Getting academia and industry to work together. So Canada, we've been trying for decades to really enhance innovation and commercialization. Unfortunately, in Canada, we're in the bottom of the OECD for business R&D investments. That's just, unfortunately, I think, a cultural piece of us. So we've been trying various different things. And in 2018, I'm at the National Research Council, so that is Canada's national labs. So how our department, how our agency addressed this was to develop these collaborative science technology innovation programs. So that's the program that I'm founding right now. And what it allows is to actually bring the 3 players together, 2 to 3 players, so that our federal researchers in quantum and end-use areas, like aerospace and whatnot, together to fund the startups, the baby startups, and the ones with a lower threshold, because that sometimes can be a key thing here. Who's eligible as a startup? Do you have enough people? Have you been around long enough? And as well as academics. And we've had some really great examples about how how the startups have pushed the academics to keep to a schedule here, but the longer term horizon pieces have been worked out and adopted into the company. So it's tricky. I think this is something we're working on, but we definitely have a few mechanisms, both within my institution and with our granting council, to try to force academics and industry to be funded to work together. And it's slowly working. But this is something I think we're all here to keep talking about.
That's very interesting. It brings me directly actually to Dr. Blatt, right? Forcing industry and startups and researchers to work together. So you're a startup CTO. You may have a different perspective on looking on these things because you have different stakes in the game, right? Then you're not, so focus, speed, agility, all these are really important to a startup. And so you are also an industrial partner in the Munich Quantum Valley. So what is your learning so far in this environment and ecosystem?
Yeah, thank you very much. Maybe let me zoom out for 1 minute and say that there are large technological goals that society, humanity may have, and quantum computing is one of them. And let me now presuppose that you've decided as a society that it's worth doing. Then everything we've talked about so far is how do we actually make that reality, right? So this starts with policy decisions that you were referring to at the highest level of saying, I think it's important, we will allocate certain resources to it. And then that falls into the next step of creating these centers, of making it possible to transfer these fundamental science ideas from research to startups. And we've seen now this be quite successful, I would say, in the UK, also in Munich Quantum Valley. Also in Canada, we were part of the Creative Destruction Lab incubator, and we learned a lot from that initially on how to even talk business and talk to people who want to make something work. And I think that's great. And then the next step is how from where we are right now as in quantum computing, I would say we are at the stage of having multiple platforms, that's what you were referring to, that are now on the brink of showing error correction. So this is the next big step worldwide, is to bring these platforms to perform better by applying quantum error correction. And this is a hard task, and it's also an expensive task. And if someone says, oh, a little startup can just do that by themselves, I think they're wrong. So it still requires this strong alignment of policy, working together with fundamental science, generating new ideas, generating talent, and putting that all together into this shared vision of getting there, regardless of what platform you may believe in. And this requires then also a certain focus. You were referring to that on a national level or an international level of, well, what do I believe in for whatever particular reason? May it be what companies exist in the particular environment, or what we're actually good at, and what maybe supporting technologies for a particular platform exist in this particular environment. So as an example, here in Germany, we have done very good policy decisions over the last 30 years. There's been a lot of money poured into the photonics industry, for example. And as a German national policymaker, I would argue, wouldn't it be smart to build on that? And this then would lead you to favor certain platforms or ideas over others. And now the question is, can these policymakers make a bold choice and focus on something, because in the end it may fail. You may bet on the wrong horse, or it may take too long. But I think what's worse is to waffle around too long. I think we're now at a stage where we have to make these bold decisions, and we have to then, from the top down, from policy through these incubator institutions like the Munich Quantum Valley, to startups, including fundamental scientists, to put this all together over the next few years. So
just to follow up on the failure piece here. So say this whole thing just doesn't pan out here. I argue that this will still be net really great for society here. So for example, in quantum networking, you need 9 orders of magnitude lower loss and 5 orders of magnitude better timing precision to even play. So if we go down hard on trying to get the applied materials and fabrications to be quantum worthy, then the whole classical semiconductor ecosystem will benefit from these things because they didn't care before that they have the materials that great. Could we leverage this type of beautiful quantum ready fabrication for data center pieces with low loss, low power? So I think and then the talent piece we talked about there, we put all this effort into quantum and this all fails, that talent is going to have a huge effect in the rest of the high-tech industry.
So I'm more optimistic. I think we don't fail.
Me too, but the stakes are sort of okay.
So I see quantum really as the next, semiconductor technology is needed, and it's also evolving. And I agree that quantum is helping to evolve it to the next level. And I think I wanted to come back to you, Dr. Blatt, because I think what you mentioned is very important. You have competition around you. You have you get on your plate error correction to be solved by 2029. And so what is the help? How can you make it work? So what would you need from the public funding, from the politics, from the academia to make it successful? What is it what you need? What would be your role? What would be the role? Because this brings that more closer to where the collaboration needs to happen and how.
Presupposing that you have a plan. Of course, we have a plan, right?
Yes.
But that plan has many aspects, right? It requires new ideas, and that requires working together again with professors, with the best research groups. That's important. And then it requires being able to get the IP arising from that into the startup. So this has to happen. And then you have to execute on it, because on what startups can be good at, what fundamental science is not good at, is scaling up. It's not good enough to build 3 or 4 logical qubits. You need to build tens, hundreds, millions of them at some point. And that's not something a PhD student is excited about. So this is an engineering task, but it needs to be fueled by all the other things that happened before. So I think this very strong alignment is important. And if we don't get that to work, I don't think we will get this to work anywhere.
Mm-hmm. Any comments?
Maybe I can add to that. I think that getting it to work is not only an institutional thing and how the boundary conditions is, it's also in the mindset of people. And that's what I experience now, in how to really make people work together means also that figuring out what is the formalities, how do you meet, how do we talk to some people from the startup, from the academia, how do PhDs work then with the engineers without having the fear that some knowledge gets lost, or without having kind of to worry about the company is taking over all that. And this we need to kind of set and then kind of find good practices and also good models so that this interaction can go along and can go a long way. And maybe what you said before, I would also point on this, so how to inform policymakers on what to focus on. I think one point could also be focus on excellence. Focus on the people that really do a good job. Don't spread out too thin, as you say, and really take bold decisions in kind of what is there already, and not trying to make everybody happy and trying to make everybody going quantum, but really also have some focus points. Good people will find out their way in what will be the best platform, the best components available.
So, Professor Wamsler, you also have, of course, very successful examples. So, how did they do it with the what Sebastian already mentioned with the IP, right? How to accelerate the innovation?
So let me turn to that in a second. I think this talent point is important, but I would say that there's actually more graduate students now go into startups than they do into, say, finance, which used to be very different 20 years ago. And I think that that's partly driven by the fact that they see something that's exciting and important for society as an end goal. And that really motivates them to be involved as well. So I think there's a really good landscape for them on that. In terms of IP, I think it's about making sure that that's access at low threshold. So the kinds of things we do. So at Imperial, it's essentially a straightforward license for no royalty fee, but there's the Imperial takes an equity stake of 10% in the company, and I think that works well because clearly you don't want to be spending cash on IP when you're a startup trying to actually make things work. But if things are successful, then everybody wins out of that. And of course, the challenge for a university is that it's not cheap to run an innovation incubation system. So you need to figure out a way in which that's long-term sustainable. And the equity model, I think, is one way to make that happen.
I've heard it argued in our ecosystem that on the talent piece, having the right people together, like what you saw at a Creative Destruction Lab, having the right people is actually more important than the best IP for that company. Because if you have the greatest IP but can't execute it because you don't have the right expertise, yet that commercialization piece isn't going to happen. So how do we develop that? That's a key challenge there. So that's a worldwide issue. How do we develop enough talent? Canada, unfortunately, that's one of our greatest exports in quantum, is our great quantum talent. But we also need more of that. That's not just the grad students and PhD nerds. We need the folks who are able to run with that in the different areas, the technology areas, the engineering pieces there. On the IP front, in Canada, we've seen varied, because certain universities have IP policies where the professor is the owner, or the person, versus the ones where the university holds it, and just the extra time it takes when you need to do that. So that has been a variable that we've seen, and as folks have been trying to move out, but this is where, since we can't necessarily afford to have each university have a really great incubator system, we've been trying to leverage across Canada the different places like Creative Destruction Labs, like QV Studios, and all these other places to try to develop and pull the companies from the babyest form to more of the ready to run.
So Stefan, I know you also have founded a company, right, or some people in your institution. So what are the challenges there of making this work and having them also being able to grow and kind of fix?
So one of the challenges is, okay, IP, we have worked this out. I think it's just getting this all done, because if you do this the first time, then it's kind of, you need to set the rules and define the rules. And the other challenge that we had was not only IP, but also really this technology transfer at the real basis, because there is machines needed. It's deep tech, so you need kind of access to not only the know-how, but the brains of people, but you need also the infrastructure.
Yeah.
And this infrastructure is kind of purposed for doing research with it, but not doing technology and not doing commercialization with it. So there were quite many hurdles that we have overcome to some degree, but I think there's a long way to go, so that we really enable then also that infrastructure use that is coming from university, where we have the best tools for research, also make them available for startups so that they can build on this. And that's kind of has taken us quite some time to figure this out. And I think that's one of the hurdles. I think besides that, just founding a company is not so easy, and getting then the money in there is kind of a job that you have to do, and that's working. But I think we'll also then get into the stage there needs to be more venture capital money growing in there and growing this whole thing up, and also more infrastructure coming that needs to be provided, because that's a lot of money that needs to go in there.
So I think that's an important point which we have not yet mentioned, this kind of infrastructure for the next level, right? Because research infrastructure is in most cases different than if you want to bring it to the next level. You need more investment, you need different sizes for scaling up, etc., which is quite important. Before we continue here the discussion, I wanted to actually remind you, get ready for the questions, because in a few minutes I will open the stage for your questions of the audience. So before we go to that, I wanted to ask one other question, is how do we better align the research goals of the university? Because there is PhD students, there is education to be done, there's a talent to be grown within the startups, which need also, different skills, capabilities, and also in the collaboration, how can these goals be brought together? And also the balance of the IP or the publication, and how does this work? So please, question to everyone. You want to start?
Certainly, yes. You're right, and as Sebastian noted, there is a lot of need for different kinds of skills within companies. So how do we do that? Well, I think there are obvious ways. Certainly, PhD programs focused around the hubs themselves have worked in the UK to build a cohort of people thinking about technology rather than just science. Second, programs focused on what we might call continuing development, so programs for policymakers, for industry partners to become aware of what capabilities are. And then thirdly, a sort of taught program. So at Oxford, we're just starting this Masters in Quantum Technology, which brings in people with clearly some STEM-related background, but from various different areas to really upskill everybody to a competent level in MQ Tech. The government funding around the quantum program has also included a lot of funding for startups to push the technology boundaries. And importantly, that's also open to university partners. So companies lead, but universities can take part. And that has also proved an important glue to enable projects to be developed with both of those sorts of capabilities.
How do you see it from your perspective?
Yeah, I think there's of course many aspects to this. I think one thing I want to highlight is we need to find ways of incentivizing PhD students better, because there's clearly a problem there where when you're working together with a research group and as a company now, and you'd like to get them to do something that's useful for you, right? Why should the PhD student care? Right, and why should they invest their time in their research work into something that's good for someone else? So there has to be some model that we have to develop together to make that useful if we want the participation of fundamental science. I think at the grassroots there's a little problem. No, there's a large problem there, and I don't have any good models in my head of how to do this, because I think this is actually a difficult problem. And but you do need these young people who are excited about what they do, because they are the ones generating the new ideas. They're the ones who have the time to play around with something cool and new, and that's where innovation really starts. And then taking these ideas and making them fly by making a product around it, making it more stable, making it better in all aspects. That's of course the job of a company. And how do we make that work? I think that's very important, and I don't have a good answer yet, but we should try to work on that.
So, but it's about incentivization in the end. You mentioned this before, also for the professors, if I remember that right?
And the institutions.
Yes.
But just to speak to this point, I think it is an important point, and one of the ways that we tackle that in the UK has been to have jointly funded projects. So partly through government funding, through research count funding, and partly through company funding, and defining a joint project so that those can be co-terminal for both the PhD student and for the company.
Okay, thank you. Let me now open to the audience. Are there questions from the audience? Yeah, there is one at the back. Yeah.
Thank you. My name is Rudolf. I have been the president of Eureka during the Canadian-German chair. And in these days, we discussed about, and still are discussing, to set up a global quantum cluster. Now, from these discussions, it became clear to me it would help to have one or several small but credible success stories. I tell you one thing, 25 years ago we set up a software cluster, and one of the first concrete example was from a Belgium SME, digital cinema. In those days it has been considered crazy. Nevertheless, it was concrete and inspired people. We can do so. Can you imagine what could be such a small, credible success story in quantum? Simulation in automotive or in somewhere in medical domain, which speeds up some processes. Help me to understand, to get back to my colleagues with a success story.
Any from your environment?
So I'm, as a scientist by trade here, data collection is something I'm very passionate about. So within my collaboration programs and the collaboration programs at the National Research Council, since my program's now starting, it was really exciting to see that a previous project in more of the classical communication space spun out a new company, and that company is applying for funding in my program. That's innovation in progress there, to be able to start counting these things. Because in science policy, if we need to be able to articulate to taxpayers, what are we getting from all this stuff here? So stories like the number of spin-out companies has happened. How many of these companies have developed a new product to be able to sell? So these are things that of course, nobody wants to fill out forms and write these things down, right? And you ask them for funding updates. But this is something that we've found, at least in our challenge programs, is by putting in the FaceTime with all of our collaborators across the country, because it's the offhanded comments that get us there. But you're right, I think we need to be showing value for all the quantum we're doing.
There's next to it also a question. Oh, sorry, I didn't see you.
Hi, thank you. How is quantum going to change our world?
So I would suggest everyone has like 20 seconds.
Okay. Well, maybe I can start. I mentioned the UK hubs. 2 of them now, in this 3rd phase, have become application-oriented. One around quantum in biomedicine, and a lot of that is around new sensor technology. So using entangled light sources to enable histology of cancer tissues in the mid-infrared, for example. And the second one of those application hubs is around navigation and timing. So when GNSS, global navigation system, fails, what do you do to keep a local flywheel? So I think there are things like that that will be in transport, logistics, and healthcare that will be the early things that we start to see.
So Sebastian, I'm sure you have another one.
Maybe I'll start with what you said. So, quantum is already changing the world. I mean, these clocks that you mentioned, I used to do that in my PhD. We were discussing in 2007 on how to put these things on satellites. It was insane because the things are like 3 optical tables. How would you do that? People are doing that now. And so these things will happen. And then specifically for quantum computing, it's a bit more of a longer story, right? We know there's mathematical proof that if the machines work, we will be able to factorize prime numbers, which has applications in cryptography. We know there's mathematical proof that these machines will be exponentially better at solving quantum mechanics problems than classical computers. It's just a question of when that will happen, not if, I think.
So I think he talked before about error correction, right? That is on the horizon within this decade. And then it's clear that there will be problems which can be solved with a quantum advantage compared to classical machines. And there's a different scaling of the performance of quantum machines to classical machines. So there's lots of things that we could fill an entire panel with this question. So let's move to the other one.
Quickly just follow up on that. The word quantum is not good enough. What you need at the end of the day here is something that's better than what classically can happen. Because we can do some of these things with quantum is great and exciting, but I think where it's really going to change the world is if we can engineer and develop something that will push the state of the art that we don't have classically.
Yeah, that was
the hype thing is an issue.
Yes.
It needs to be showing business value, at least a strong path to that to change our world.
And that's kind of announced for next year and under a correction by 2029. So I think you can expect that pretty soon. Though have really an advantage compared to classical systems. Then there was a question.
Yeah, I just wanted to ask a question, sorry, about, we've spoken a lot over the last few days about innovation, what we can do to bridge the gap. No one's really spoken about tax or bureaucracy. So how do you incentivize someone, and I say this as a partner of someone who's founded companies, to take on that responsibility? How do you help them see the next level? So it's one thing to have an idea, it's one thing to scale up. But when you are a founder, there is a responsibility that not everyone is suited for. How do you help them?
So this would have been a really great question for Markus Blume. Unfortunately, he's not here. So who wants to take it?
Well, let me tackle a little of it, though as a co-founder of a startup also. So I think there are a couple of things. One is when you're starting that, making sure that you have the right incubation system and network, so you've got connections with people who can help you and draw upon. And part of that is about access to business advice and legal advice and what have you. Part of that's about having a good board of people who have done this before and can help you steer through some of the things that they've done before and you'll doubtless come across. I think that all those are helpful. I think having a ecosystem that's of critical mass, so that you're in a region where there's lots of others going through the same thing, so that you can share experience and combine and what have you. all of these things are an important element of that. Ultimately, there's no risk. There's nothing without risk in this, and so you also want to make sure that your company's structured so that if it's a success, the CEO and the founders do well out of it.
Maybe briefly to add on this, I think it's also then putting into the mindset that there is a risk, but what is the risk actually? If the startup fails, then you've learned quite a lot. You do a new startup, or you do something else. There is so many opportunities, and I guess all of the people that are starting now here with a new company, they are bright minds, so they will find their way in life. And I think it's just one experience, and we all hope and we are confident that it will work out. But if it doesn't work out, okay, then try the next thing. And I think it's also a mindset question that has to go in there, that you have to try something.
We have room for one other question. I think you were before already. Sorry, but I may have not seen you.
Okay, I want to come back what we kind of started earlier. What's the end game of our European societies? Because like there was Oxford Ionics, big company, bought for 1 billion by IonQ. So is this our European end game, that our startups in the third round will be bought by US companies? And if not, what we gonna do about it? So what's happening 5 years with startups we see now?
What's the landscape? Yeah, I sure hope that isn't the only outcome. I think that, notwithstanding the points made about making a big, bold bet now, I think we'll actually be better off in competitive terms in having a number of different options here. I think we don't want to go, everything goes to the US, and I think we don't want to be in the straits where we have 2 or 3 very, very high-powered companies dictating everything for the rest of the world. So hopefully we can grow some of those. Well, Planck will be one of them, no doubt. That's going to be one of those unicorns for the future for Europe. Yeah.
And maybe let me add to this. I think the reason why that's happening is because there are, I mean, this is a well-known thing in venture capital that around round sizes of a few hundred million, it gets difficult to find the people to finance that in Europe. And I think there are now very large initiatives starting to fix that. I mean, there's a new fund that was just announced by the EU, which is specifically made to tackle these problems. And I think the awareness is there on the political side, also I think in Germany. But in the end, it's a lot of money, and someone has to be willing to put that up. There's the option of doing it similar to in the US, where the pension funds, for example, are allowed to invest. That's another regulatory thing that you can consider. Of course, there's risk associated with that, but that's how they're doing it in the US. And if we want to do the same thing, that's one option.
I think that's a very important point you mentioned, that it's not only on the politics, it's not only on someone else, it's also on all of us, because we also need to then take some risks and invest our own money into these type of things, right, as a European community. Good. We are actually almost coming to the end, right? So I have actually a final question for the 4 of you, for each one, and I would like to really ask you to be concise and say it in 30 seconds. And it's the most important for this conference. What is the next step we have to take to break down the wall to transfer quantum computing from the lab to the application? Stefan, go ahead.
So the wall that we need to break down is there's 2 things. There's the bureaucratic wall. We need to make it easier and simpler to get this transfer done and encourage this exchange between academia, research, and technology, and then startups. And the other thing is we just need to build the hardware to find, to actually come to this quantum error correct and make it understandable what is the value of quantum computers.
Hot take. It's not about quantum computing. The wall we break down is quantum computing isn't the synonym for quantum technologies, but how can we drive and follow the walls here for sensing, which will be commercialized first, and networking and computing, and be able to push all of this together and the intersections therein.
Thank you.
Yeah, I think we, as you mentioned, we have to show the world that quantum computing is good for something. And the first step is to get our act together politically, I think.
Yeah.
Quantum-enabled commercial advantage.
Thank you. That kind of summarizes already very well. I really appreciate all your comments. What I've heard is that there's lots of good investment. There's also lots of good outcome. I think we can be proud also that lots of talent have been created over the times and startups and everything has been achieved. We need to have a long vision. I think that became also clear out of the discussion, and a plan. Quantum is something where we envision what we want to do. In some cases, it's already more clear. But what also has to be clear that there is so much to be invented still, and we don't even can know right now what we be able to do in 20, 30 years, and what new opportunities may be created also by all that work which is currently done. Incentivization is a problem, or there has been already good examples, but there is more to be done in all the different areas. Focus, that's very important for the next levels also of success and commitment, and collaboration. And I think also here we discussed good examples, very successful examples, and there are also things we can all work together. And for this, I thank you very much for you here in the audience, but also very, very much my distinguished panelists here in the auditorium. Thank you very much.
Thank you.